Good morning, everyone. Welcome back to SSR Concepts. Learn easy with us. Okay. Today's class, we will go further deep into our topic. If you check my previous video, in that we have already discussed about the sources of light, what is the medium required for the light, and what are light rays, what are their, how they classified the convergent, divergent, and parallel rays, and what are reflections, what are the laws of reflections, what are mirrors, the plane mirrors, and the spherical mirrors, and how do images form in a plane mirror and spherical mirrors. Today's class, we will discuss about further how images are formed in plane mirrors and spherical mirrors, and what are the important terms that are related to these spherical mirrors. You have to know each and every definition of these. Okay, shall we move into the topic of show? Let me first share my PPT. Okay. In the previous class, we have discussed about the mirrors, right? In that, we have seen what are mirrors, what are plane mirrors, and what are spherical mirrors, and how spherical mirrors are again divided into convex and concave mirrors, and how do these concave mirrors appear, and how do these convex mirrors appear, and their reflecting surfaces according to their reflecting surfaces. Now you have to learn formation of images in a plane mirror. In the previous class, I have just introduced how the image is formed, right? How the image is formed. Children, already we have discussed the image is formed where the incident ray and reflected ray meets at a particular point. You already know where all the rays come and meet at a particular point. Okay, all the rays come and meet at a particular point. There, the junction where both the reflected and the incident ray met, there the image is formed. You can see in this figure here, this is the incident ray and this is the reflected ray. Just you imagine the lines to be extended. Here is the point where, this is the point where the incident ray and the reflected ray met, right? This is the point where you can observe the image. You can see the image here. Okay. If you see this point, the image is formed here. How these images are appeared in plane mirrors and the spherical mirrors. You have to find out that. Okay. Images are formed. We know. By now, you know where the rays get met at one point, the images are formed. How do these images appear in a plane mirror and how do these images appear in a spherical mirrors? Okay, in plane mirrors, you have to remember, children, in plane mirrors, always the image is virtual. Always the image formed is virtual image. Virtual in the sense it is not real. Virtual means not real image. Always plane mirrors forms the virtual image. Here you can see in this figure, always the plane mirrors forms virtual images. And how do these images appear? Always in erect position. You can see the reflected ray and the incident ray met. Always this image is in erected position and means upright position. Upright position. Always your head shows upside only, right? Can you see your image in the mirror, the head downside? No. This is how always the plane mirrors forms the virtual and erect image. Always the plane mirrors forms the virtual and erect image. And here one of the most important point, the size of the image appears as of the same as the object. For example, if you taken this one, this is an object, and if you show this in your mirror, the size of the image appears same as the object in the mirror, right? Here in the plane mirror, the size of the object is always same in the mirror also. So by now you got 3 points. Always the image is virtual, always the image is in erect position, and the size of the object is same. Okay, this is how the images are formed in the plane mirrors. Okay, this is how the images are formed in the plane mirrors. And you have to know one concept. What are the multiple reflections? We know what is reflection. Nothing but bouncing back of the light in the same medium when it strikes an object. We have discussed the definition and the laws of reflection in the previous video. Once go and check that video. And here you have to know one more concept, multiple reflections. We already said light ray always travels in the beam. No single ray is travel. It always travels in beam. So we call beam of light passes. Beam of light passes. Here what happens? Here what happens? For multiple reflections to form, what is needed? To form a multiple reflections, at least 2 rays are required. At least 2 light rays are required. You also know the one is incident ray and one is reflected ray. You can say one is incident ray and one is reflected ray. Here, see this figure. This is the incident ray which comes and strike in the object, and again it is reflected back. This is the reflected ray and this is considered as normal. Okay. Again this reflected ray acts as in one incident ray, and again this one strike in the object. No? This one again reflected back. So here you can see, here this is the point. This is the point where here, this is the point where one image is formed. This is the point where one image is formed. This is the point where one image is formed. Here, more than one image is formed, right? So here you can say multiple images are formed. This is the concept of multiple reflections. This is the concept of multiple reflections. For the formation of multiple reflections, at least you require 2 rays. One is incident and one is reflected ray. You require at least 2 rays. Understood, children? What is multiple reflections? Now coming to the spherical mirrors. You already learned the spherical mirrors are nothing but the curved mirrors. Spherical mirrors are nothing but the curved mirrors. And here, these can be classified into concave and convex mirrors. These can be classified into concave and convex mirrors. We already discussed what are concave mirrors, what are convex mirrors in the previous video part 1. Just you refer to that. Just simply I will say concave mirrors. Concave, a line in a cave I said, means inside the reflecting surface, always towards inside, towards inwards. Right. Convex mirrors or the mirrors where the reflecting surface is always outwards. Reflecting surface is always outwards. Right. Here, you have to know how the images are formed in these spherical mirrors. By the way, now you got how the images are formed in plane mirrors. How the images looks in a plane mirror. Always virtual. It is a not real image, and the image formed is always erect, and the image is same as size of an object. These are one of the important points you have to learn in the formation of images in the plane mirror. Right. Now coming to the spherical mirrors, how the images form in concave and convex mirrors. How the images are formed in concave and convex mirrors. Right. You have to know that. Here, what I said, always the concave mirror, the reflecting surface is towards inwards. Reflecting surface is towards inwards. This is reflecting surface towards outwards. Convex mirrors, always the reflecting surfaces are outwards. Here, for the plane mirror, the image is always found behind the mirror. Yes. For the concave mirrors, always the image is formed towards inwards. Right? Convex always forms the image behind the mirror. Before going deep how the images are formed in the spherical mirrors, you have to learn some of the terms which are related, very important terminology that is related to this topic. Okay, what are those terminologies you have to consider here? What is a pole? What is center of curvature? What is the radius of the curvature? What is aperture? What is principal axis? What is principal focus? What is focal length? Okay, what is focal length? How the principal focus you can see in concave and the convex mirrors. These are all the points, these are all the definitions you have to know, and these are very important for your IPA, for your 2 marks answers or the 4 marks answers. And you can also assume a question for you in your need bit. Learn carefully. This is very interesting and easy topic if you understood the concept. Okay, so let me see the definitions of this. By showing the figure, I will explain. Just you remember the images in your mind, so that you can write your definitions very easily if you understood the concept. Okay, this is, we have discussed, this is the concave mirror and this is the convex mirror. Now, the first definition, the first one, you have to know what is a pole. What is a pole? So this is a mirror. See, just you check the figure where I'm keeping the arrow mark and just you assume what I'm explaining. This is the part. This is the part of the mirror, right? This is the part. This is the part of a concave mirror. So this part, for this part, if you know this one is the concave mirror. For this part to be get, you have to be, there should be a sphere. There should be a sphere. This is the one sphere. This is one sphere. If you cut this sphere, if, for example, this is a ball you think, if you cut this ball only, you have to get this part. Right? There should be a sphere here if you want to get this part. Right? Now, what is a pole? What is a pole? This the center point of reflecting surface. This is a concave mirror and these are the rays which are striking. These are the rays which are striking. Here, this is the center to this. This is the center point to this reflecting surface, right? Here you can see this is a complete part of a concave mirror and this is the center point to this. The center point of the reflecting surface of a mirror is called as pole. Children, understood? This is the concave mirror and this is the convex mirror. This is the convex and this is the concave mirror. Simply the center point of the reflecting surface. The center point, this is the center to this and this is the center to this. The center point of the reflecting surface is called as pole. Once again, I am telling the center point of the reflecting surface. Just you simply remember the reflecting surface is there. To this reflecting surface, the center point is considered to be as a pole. Okay. You got to know what is a pole. The second one is center of curvature. Right? What is the center of curvature? We have discussed the center of the reflecting surface is a pole. The center of the reflecting surface. This is the convex mirror or the concave mirror. If you think this is the center part. This is the center part which is considered as a pole. Now we have to consider what is center of curvature. What is the center of curvature? For the formation of any mirror, there should be one sphere. If there is no sphere or if there is no ball, how can you cut a part in it? You have to assume there should be a sphere. Right? This is the sphere. You can see in this image. This is the sphere. This is the sphere. To that sphere, there is a center. Right? To that sphere also, there will be a center point. This is the center point. This is the center point for this entire sphere. Right? This is the center point for the concave or the convex mirror what we have taken. And this is the center point for this sphere. Just simply remember, if there is no ball, how can you cut? If there is no apple, how can you cut into a part? There should be complete apple to cut a part of that. Right? Here, after cutting the part of an apple, there should be a complete apple here. So, this is the part you have taken. This is the concave or the convex mirrors. To get that concave or the convex mirror, that curved mirror, you have to get here. You have to See the complete sphere here, right? Here, the center point of the sphere is considered as center of curvature. Okay, simply remember the center point of the sphere is a center of curvature, and center point to the reflecting surface is called as pole. Just understood, children? The center point to the sphere is called as center of curvature, and the center point of the reflecting surface is called as pole. Now, what is this radius of curvature? You have to get what is this radius of curvature. Pole, center of curvature, you learned by now. And what is this radius of curvature? What is this radius of curvature? The reflection, this radius of curvature, the distance between here, the distance between, you can see in the figure, just I am keeping the arrow mark. You can consider this is the distance between the center of the curvature and the pole. The radius of curvature is nothing but the distance. This is the center of curvature and this is the center of a pole. This is the pole. This is the center of reflecting surface is known as pole. This is the center of curvature which is considered in the sphere. The distance here, the distance between these 2 points, are considered to be radius of curvature. Radius of curvature, okay. For example, you have taken, these are the two objects. Okay, this is the center, this is the pole. This is the pole, you think. This is the pole. Means the center point to the reflecting surface. The center point to the reflecting surface. This is the center of the curvature. This is the center of the curvature. Means this is the center for the sphere. Here you can see this, to these two objects there is some distance. This distance is known as radius of curvature. Understood? This distance is known as radius of curvature. And what is aperture? The exact part, where the reflection takes place. For example, this is a concave and this is the convex mirrors. You can, where the reflection is going to take place, from this point to this point. If you assume this is the M point and this is the end point, between these 2 points, the reflection is going to happen. This is called as aperture. This is called as aperture. Understood, children? This is called as aperture. By the way, you came to know pole is center of a aperture. Nothing but this is what is aperture? From here to here. The reflection, where the reflection takes place is called as aperture. So you can consider a pole. What is pole? This is a pole. This is the center point to this complete aperture. This is the center point to this complete reflecting surface. Nothing but the aperture. Right? Pole is a center point to the aperture and center of curvature is a center point to the sphere. And the distance between these 2 points, center of curvature and the pole, is called radius of curvature. These two, distance between these two are called as radius of curvature. Up to this, you clear? Understood completely? What is pole? What is aperture? What is center of curvature? And what is the radius of curvature? Here, if you understand the terms, the topic is very, very interesting and easy. And now, what is principal axis? What is principal axis? Okay, this is the line drawn. This is the line drawn from the center of curvature to the pole. This is the line drawn from the center of curvature to the pole. Principal axis is an imaginary line drawn through the center of curvature and the pole. Okay. From here, this is the complete sphere. From this sphere, the complete imaginary line you have drawn here. Okay, from here to the here, the imaginary line is drawn through center of curvature and pole. Half of the way you know center of the curvature and the pole. From the pole to the center of curvature, radius of curvature. And the extended part, you have extended the line. You have extended this line to the complete sphere. And this complete imaginary line is called as principal axis. Okay, understood? There is nothing, if you understand the concept, here from the pole to the center of curvature is the radius of the curvature. From the pole to the center of curvature, if you extended the line to the complete sphere, the imaginary line what you have drawn is called as principal axis. Principal axis. Next, coming to the principal focus. Next, coming to the principal focus. Here, the point, once you see this is the pole. Okay, this is the pole definition and center of curvature and radius of curvature. You can see what is aperture, what is principal axis. You can see in this slide. And now here in this figure, you can see the principal axis. What is principal axis? I said this is the center of the curvature and this is the P represents the P represents here the pole. This is the nothing but the reflection part, reflected surface, the center of the reflected surface. That is nothing but from M to N, you can consider it as an aperture. If you consider an aperture here, the center point of the aperture is known as pole and the center part of this complete sphere is known as center of curvature, and the distance between the center of curvature and the pole is called as radius of curvature. And if you extend, if you draw a complete line, an imaginary line through the center of the curvature and the pole, this extended line is said to be the principal axis. Here you can see here the principal axis. This is the concave and this is the convex mirror, right? You can see the principal axis. Now what is the principal focus? What is this principal focus? Here you can see in this figure what is the principal focus means. A point on the principal axis. Here this is the center point. This is the center, the imaginary line you have drawn through the center of, this is the center of curvature and this is the pole. Okay, if you can consider here, I have taken only the concave mirror here. I have taken only the concave mirror here. This is the center point of the center point. So this is a pole and this is the center of the curvature here, where all the light rays come and meet a point. That point is said to be principal focus. Here, all the reflecting surfaces, all the light rays come and meet at one point. Here, what is happening? All the light rays, these are the different light rays which are reflecting. These are the different light rays. All these came and met at one point. This is called as focus. Meeting at one point. All the light rays come and meet at one point. That point is called as principal focus. That point is called as principal focusing. Focusing at one point. All the light rays are focusing at one point. Okay, that is nothing but principal focus. That is nothing but principal focus. What is principal axis? We have discussed imaginary line. The imaginary line drawn from the center of curvature to the pole. So all the light rays come and meet at some of the point of this on the principal axis. All the light rays should come and meet at the principal axis. So where the point where all the light rays met is called as principal focus. This is the point where all the light rays come and met. So this is nothing but the principal focus. Here the principal focus you can observe two different ways in the concave and convex mirrors. In the concave mirror, here what's happening? All the light rays are coming and meeting at one point. In the previous class, if you remember, I have discussed a topic of light rays, convergent rays, divergent rays, and parallel rays. So you have to implement here. If all the light rays come and meet at one point, what are those rays called? Converging rays. What are those rays called? Converging rays. This in the concave mirror, okay, convergence of reflection is taking place. This is one of the important need bit. If you observe in a concave mirror, what happens? What type of reflection you can see? Convergence of reflection you can see, because here all the light rays are coming and meeting at one point. Converging of light rays are taking place. So in the concave mirror, convergent rays form. Convergence of reflection is, you can see. In the convex mirrors, if you see, you can see diverging of rays. Here all the rays from the point diverge. For example, this is the convex mirror. You can see here what happens. All the light rays forms, image is formed behind the mirror. In the convex mirror, image is formed behind the mirror. So all the light rays are scattering from one point. All the light rays are scattering, reflecting back to a point. Here divergence taking place. Diverging rays are seen here. So divergence of reflection is seen in convex mirror. Divergence of reflection is seen in convex mirror. Okay, by now you got to know how the images are formed in plane mirrors, how the images are formed in a spherical mirrors, and you got the terms what are related to this: pole, center of curvature, radius of curvature, what is the principal axis, what is principal focus, and based on the principal focus, the convergence of reflection and the where the convergence of reflection takes place and where the divergence of reflection takes place. Understood? And now focal length. Now what? Focal length. And one more important term related to this topic is focal length. What is this focal length? Here, based upon this focal length, you can get one question or one sum in your NEET or in IP. Okay, a simple question you can get related to this topic. What is the focal length of the concave mirror? What is focal length? Distance between, okay, you can see the distance between pole, this is the pole, and the principal focus. Here, this is the principal focus. Here you can see in this image. This is the pole, this is the center of curvature, right? This is the center of curvature and this is the pole. Here, all the light rays come and met at one point. That is nothing but the point is called as focus. Here, the distance between this principal axis and the pole. Distance between this principal axis and the pole is called as focal length. Okay, focal length. Before, we already discussed the distance between the center of curvature and the pole is called as radius of curvature, right, children? Distance between the center of the sphere and the center of the aperture is called as radius of the curvature. Here, in between the center and the center of curvature and pole, you can see the principal focus. Principal focus. That the distance between this focal focus, principal focus, and the pole is called as focal length. Okay, the distance between these two is called as focal length. So you can observe R is equal to 2f, means R is radius of curvature. 2f means focal length. F means, small f means focal length. R is equal to radius of curvature is equal to 2 focal length, 2 times of the focal length. Why? How you got that? This is the radius of the curvature we are thinking. From the center of the sphere to pole. This is completely called as radius of the curvature. Focal length is up to the half of the way. You can see the principal focus. Here, this is the focal point, which is half to the radius of the curvature. This is the radius of the, this is complete thing is called as radius of curvature. And here you can say this, from here to here one part, and here to here one part. Means here to here, this is one focal length and this is one focal length you can consider. So, R is equal to 2f. Radius of curvature is equal to 2 times of focal length. You can see here again, if they asked in a question, if they have given the radius of the curvature and they ask you to find out the focal length, you can short that one. F is equal to R by 2. F is equal to R by 2. Now, one of the example I will say, just you do, children. If the mirror has a radius 30 centimeters, radius means R they have given 30 centimeters. They have asked to find out focal length of a object. Now we know radius is equal to 2 times of the focal length. They have asked the focal length. You can use this formula. Focal length is equal to R by 2. They have given the radius as 30 centimeters, right? 30 by 2 is equal to 15. So you got to know the focal length of an object. This is how the sums you have to do. Children, understood? In this class, we came to know how the images are formed in a plane mirrors, how the images are formed in a spherical mirrors, and what are the terms that are related, what you came to know, what is a pole, what is the center of curvature, what is aperture, what is radius of the curvature, what is principal axis, what is principal focus, what is focal length, and the sum related to that. Okay, further we will discuss in the next class. Thank you one and all. If you do like, please subscribe my channel, Assessor Concepts. Thank you all.